Hello students, myself Supriya Prabhu, Assistant Professor in the Department of Chemistry, RNSL. Today let us discuss about potentiometric estimation of FAS by using K2CR47 solution. Here potentiometer, it is an instrument used to measure the change in the potential, and potentiometric titration, it is nothing but the estimation of substance by measuring the sudden change in the potential at the equivalence point. So the principle behind this experiment is based on Nernst equation, which says E equal to E naught plus 0.591 divided by N log of oxidized form divided by reduced form of metal ion species. The apparatus used for this experiments are a burette, which is filled with K2Cr2O7 of known concentration, and a potentiometer which is connected to two electrodes, that is calomel electrode and platinum electrode, and in the beaker you have ferrous ammonium sulfate solution along with that one test tube of H2SO4. So these are the apparatus taken. Now when you perform this experiment, you are adding 0.5 ml of K2Cr2O7 to the beaker solution which contains FAS. Okay, that time the reaction happens is the ferrous which is there in +2 oxidation state will get converted into +3 oxidation state. That is because of the K2Cr2O7, which is a oxidizing agent. The meaning of oxidizing agent is it oxidizes the other molecule and itself, which is there in +6 oxidation state, will get reduced to +3 oxidation state. This happens only when the beaker has acidic medium. That is why we are adding one test tube of H2SO4 to the beaker. So initially in the beaker you have FAS solution where you have only Fe2 plus ions. Now when electrodes are dipped, the potential generated is because of only the Fe2 plus ions which is there in the beaker. As you add 0.5 ml of dichromate, some of the Fe2 plus ions get oxidized to Fe3 plus. So the potential generated is because of the concentration of Fe3 plus to Fe2 plus ions. As you keep on adding 0.5 ml of K2Cr2O7, the concentration of Fe3 plus ions increases and the concentration of Fe2 plus ions decreases. That is why the potential value will keep on increasing. At one point, you observe that all the Fe2 plus completely get converted into Fe3 plus, and that time the potential generated is because of the concentration of chromium +6 to chromium +3 ions, and this is called as equivalence point. Once we perform the experiment, we are going to plot the graph of delta E by delta V versus volume of K2Cr2O7 to get the exact equivalence point value. Let us see the demonstration now. The solution required for this experiment is FAS solution, dilute sulfuric acid and K2Cr2O7 solution. In the beaker, we have taken 25 ml of FAS and a magnetic bed. For this solution, we have to add one full test tube of sulfuric acid. This solution is placed in the magnetic stirrer and the electrodes are dipped in the FAS solution. So here this is the calomel electrode and this is platinum electrode. Remember, calomel is a reference electrode whose potential is already known, and platinum electrode, it's an indicator electrode. This is also called as redox electrode. These electrodes are washed and it is placed in the FAS solution. In the burette, we have taken K2Cr2O7 solution. Now, switch on the instrument. After writing the initial potential value, you need to add 0.5 ml of potassium dichromate solution from the burette. And for every 0.5 ml, you need to note down the change in the potential value. You observe that the potential value increases because the Fe2 plus ions which is there in the beaker is getting oxidized to Fe3 plus form, and the platinum electrode will measure the change in the potential for Fe3 plus ions to Fe2 plus ions. And also you will observe that in the beaker the solution color is changing. It is turning into greenish blue color. Here green color is because of chromium plus 3 ions, and the blue color formation is because of Fe3 plus ions. Note down these potential values for every 0.5 ml of potassium dichromate solution. At one point you will observe the jump in the value. That potential jump is noted. Look at the potential value now. The previous value for 5 ml, it was 455, and now when I added 0.5 ml, that is 5.5 ml, the potential value is drastically changing. It is increasing drastically. This jump in the value indicates the equivalence point. Now at this point, all the Fe2 plus ions has completely converted into Fe3 plus ions, and the chromium concentration is more now. That is, chromium plus 6 ions and chromium plus 3 ions are there in the beaker. That is why the potential generated here is because of chromium plus 6 to chromium plus 3 ions. Now note down the potential, wait for some time, it shows constant potential value. Note down that potential, and after this jump you need to note down extra 5 to 6 readings. Now we have taken 6 more readings. Now switch off the instrument and wash the electrodes and place it in the clean water bath. So these are the values, we got it from the experiment. Now we need to find the delta E. So to find delta E, we need to take the difference of the potential. Here 311 minus 291, that is 20. 328 minus 311, that is 17. Likewise take all the difference. Now delta E divided by delta V, that is delta V is 0.5 ml. So delta E is 20 divided by 0.5 ml, that will be equal to 40. 17 divided by 0.5 ml, that will be Likewise, take all the readings. For these values, we need to plot the graph. Graph is against delta E by delta V in the y-axis versus volume of K2Cr2O7 in the x-axis. Now if you see, the first value is 40. So for 0.5 ml, the value is 40. Mark and round it up. Second, for 1 ml, the value is 34. Likewise, if you do the calculation, you will get all the values somewhere below 100. Mark all those points in the graph. Now if you see, for 5 ml, the value is 70. And for 5.5 ml, the value goes to 720. So for 5.5 ml, the value is 720. The next value for 6 ml is 10. So like this, mark all the points. Now you need to join all these points. So when you join all these points, you need to use a scale from peak point to the very next point by using scale. And remaining points you can draw it freehand. Now the peak point is nothing but equivalence point. Draw a line to the x-axis by using scale. And put an arrow and mark it as a equivalence point. That is equal to 5.5 ml. By using this equivalence point, we will find out what is the strength of FAS taken. Now let us do the calculation. Normality of standard K2Cr2O7 solution given in the laboratory is 0.5 normal. Volume of K2Cr2O7 consumed, from the graph we got 5.5 ml, and the volume pipetted FAS solution is 25 ml. To find the strength of FAS, we need to use the formula N1V1 equal to N2V2. So strength of FAS is equal to normality of K2Cr2O7 into volume of K2Cr2O7 divided by volume of FAS. So it is 0.5 into 5.5 divided by 25, that will be 0.11 normal. Now weight of FAS present in 1 liter is normality into its equivalent weight, that is 0.11 into 392, we get 43.12 grams. So 43.12 gram is there in the 1 liter solution. Now let us find how much is present in 25 ml. So weight of FAS in 25 ml given solution is 43.12 into 25 divided by 1000, that gives 1.078 grams. So the result, normality of given FAS solution is 0.11 normal, and weight of FAS present in 25 ml of solution is 1.078 grams. Thank you for listening. Happy learning.